In today's video, presented by Good Drive, we'll be touching on these few points. First will be the working principle of maglev train, Faraday's law, and Lenz's law. Next, we will learn how a maglev train levitates and propels. Thirdly, we will learn how to differentiate the two types of maglev train. And lastly, we will learn about the electromagnetic suspensions and electrodynamic suspension. So, the first content would be the laws related to maglev, Faraday's law by Michael Faraday, and Lenz's law by Emil Lenz. Faraday's law states that any change in the magnetic environment of a coil of wire will cause a voltage EMF to be induced in the coil. The equation below is the equation invented by Faraday's law. T stands for the EMF, and that circle with a line being through it is the magnetic field, and T will be the time taken. I'm sure some of you have learned at maths before, and from this equation we can tell that D is the rate of change. So from this equation, if we put it into words, it will be the rate of change of magnetic field. A very good example of Faraday's law will be a moving magnet into a coil of wires. As the magnet moves into the solenoid, you can see that the magnet deflects, and when the magnet remains stationary, there's no changes in the ammeter. Moving on to the Lenz's law. Lenz's law states that when an EMF is generated by a change in magnetic flux, the polarity of the induced EMF is such that it produces a current that's magnetic field opposes the change which produces it. A very good example is when you move a magnet into a solenoid. That end of the solenoid will change into a south pole to oppose that action and to repulse it. So as you pull the magnet away, the end of the solenoid will turn into north pole to oppose that action. Moving on to the Lenz's law equation, you will realize that the Lenz's law equation is the same as Faraday's law equation, but actually the Lenz's law is the negative sign of the Faraday's law. It's as simple as that. The reason behind it is because it produces a current that's magnetic field opposes the changes which produces it. It says it opposes. That's why it's a negative sign.
First of all, let's talk about how is maglev train invented. Trains are the vital link for transporting people as they carry out their daily lives. But as we strive for an ever quicker future, the trains that have been transporting us for centuries are no longer able to keep up. The problem? Friction, and a solution? Maglev. The vision of maglev began in the early 20th century with two men, Robert Goddard and Emily Bachelet. Their dream was to develop a transistor that was faster, safer, and more reliable. Thus, they turned to electromagnets. Since then, many countries developed the faster maglev system. So, what is maglev train? The big difference between a maglev train and a conventional train is that maglev trains do not have an engine, at least not the kind of engine used to pull typical train cars along steel tracks. The engine for maglev trains is rather inconspicuous. Instead of using fossil fuels, the magnetic field created by the electrified coils in the guideway walls and the track combine to propel the train.
Moving on, maglev train operate through levitation and propulsion and lateral guidance. It first levitates, then it is launched or propelled through propulsion system, which causes it to move along the guideway. which is also another name for tracks. And once on the track, it is controlled by lateral guidance, which essentially prevents the train from being derailed. Generally, Lenz's law and Faraday's law causes the train to levitate and also propulse at the same time. This law causes changes in magnetic fields, which causes repulsion and attraction, and hence it causes repulsion and attraction between the train and guideway, which causes the train to levitate or propulse. We'll look deeper into our example EMS. One of the examples of electrodynamic suspension maglev trains are the SC maglev train. It is made in Japan. It is one of the latest technologies so far for this system, and it is currently still in prototype, which is still not available commercially. At the right, you can see that this is a picture that describing how it actually works, how the diagram is. As you can see at the left, it is a picture talking about the levitation and also the propulsion, where as you can see at the left, it is the real picture in real life. And at the left here, you can see it's the magnets arranged together, and also here these are the magnets beside the train, which causes it to levitate and also propulse. Electrodynamic suspension in maglev train. One of it is now flux, which is used in SC maglev train. How is it like? As mentioned before, it uses figure eight shape and magnets, as you can see here. So how does this system works? It produces magnetic field through relative movement between the magnet and coil, and hence it causes it to levitate. But when it is centered, no current flows since the potential cancels out. This statement right here will be enlightened soon. But first, we should know how this train levitates. It uses superconducting magnets, which is cooled to negative 196 degrees to cause it to levitate, which is to exploit the Meissner effect. And because of this effect, it produces eddy currents, which produces in the egg-shaped coils to produce an opposite magnetic field, which causes the train to levitate. This is during when the train is at stop. The coils are magnetized by induced by current flow into it, which is connected to an external power source like a power station to cause it to levitate. And once it levitates, it moves, right? It moves by propulsion system. And when during motion, levitation is also happening. How? So imagine this. When the train is moving, it causes magnetic flux to change. So as you can see here, the relative motion between the supercooled magnets and coils increases. Change of magnetic flux increases rapidly, and hence induced current is produced, and it produces a current which flow in such way in accordance to Lenz's law, it produces an opposing magnetic field. And this opposing magnetic field is due to the current. This current flow direction is determined by Lenz's law too. Hence, this current flow will flow in a closed loop in egg-shaped coil, which is also known as the eddy current, to produce a repulsive force due to this opposing magnetic field. Using this phenomenon, induce current flow in different directions to create a repulsive and attractive force acting on the train. This statement here says that how the egg-shaped coils, the current flow differently to cause these two forces to be produced, which levitates the train. We'll look into it to the next slide. How does this all happen? So this is the SC maglev train guideway. It is confined in a U-shaped reinforced concrete, and the carrier is at the center of it, and it is produced by opposing magnetic fields and also attract magnetic fields to cause the train to levitate, and it is done by the superconducting magnets on the train here, and also the aluminum electromagnets. We look into here, so this is the superconducting magnet and this is the egg-shaped coils, and the egg-shaped coils, the current flowing into will flow in different directions to cause the attractive and repulsive force, which is due to Lenz's law, to cause it to levitate, and produces an opposing and attractive magnetic field, which can be explained by Lenz's law to produce attractive and repulsive force to cause it to levitate. And this system is installed in both sides to cause it to levitate in equilibrium, and hence it does not need a feedback loop to control it because it is relatively stable, especially in motion. So how does the maglev train go about? It is done by propulsion system. With help of propulsion system, it consists of linear synchronous motor and also alternating currents to switch polarities of the figure egg-shaped coils. So this is how it alternates. So by the frequency of the AC current, it switches the polarity and hence controlling how fast the train moves and how fast it accelerates. It is also due to the Lenz's law and Faraday's law of electromagnetic induction happening between the coils and the superconducting magnets. As you can see here, which produce repulsive force here and also an attractive force, hence causing it to move. Plus, with AC current, it can move in a rhythmic way, which the polarity changes in a rhythmic way and causes it to move. Furthermore, the linear synchronous motor. This is just a system with additional levitation and guidance cell, propulsion cell, which is an additional circuit to cause it to levitate and also propulse at the same time. See, superconductivity of this superconductor is induced by pouring liquid nitrogen into it and lowering it to its critical temperature, and hence it causes this magnet to levitate. The magnetic field from this magnet does not cut through superconductor, and hence it will produce eddy currents at the surface of the conductor, and it causes it to levitate and to exhibit diamagnetic properties at the magnet, which is the meaning of this property is to be repulsed by magnets, and hence it levitates, which is used in maglev trains, especially the electrodynamic suspension. So about electromagnetic suspension maglev train, how they levitate? They levitate through the principles of opposite poles of magnet, and thus it attracts and levitates. How does this do? The electromagnet will be located under the guideway, and the magnet is attracted to the electromagnet. First, the electromagnet will be magnetized, and then the magnet will be attracted to the poles. It is attracted to the electromagnet, it moves upwards. When it moves upwards, it produces, which can be explained by Lenz's law. So the eddy currents produced will produce an opposing magnetic field that will cause the train carriage to go down and go up simultaneously. When it goes down, it changes the eddy current direction, and then it causes a magnetic field which is attractive and cause up and go down simultaneously, and hence this incompatibility, it is controlled by a computer feedback loop to control how many current is go into the electromagnet to control the train to take balance on the guideway. Furthermore, you can see in this picture where, as you can see, the red bars here are the permanent magnets and the green bar here are known as the stator. It is also known as the electromagnet. So this will attract this and cause it to levitate, as explained before. For propulsion for electromagnetic suspension, it is similar to EDS system, and because it uses linear synchronous motor, as you can see, this motor, the meaning means the same. It's like a regular motor, but it is in sync together, where the magnets and the coils sync together to produce a force, and hence it projected linearly instead of cylindrically like the DC motor that we used to know in school. And it is also held by propulsion coil, which is the alternating currents to cause it to propel forward by producing forward and force that are dragging behind.
So, what's the differences between EMS and EDS? For EMS, EMS uses attractive force system to levitate. And for EDS, EDS uses magnets that has same polarity to create repulsive force between levitational magnet and guideway magnet. And EMS uses standard electromagnets. The coils only conduct electricity when a power supply is present. And for EDS, supercooled and superconducting electromagnets are used by EDS. Last but not least, this is the pros and cons for EMS and EDS. The pros of EMS is they have longer lifetimes, lower operating costs, faster and quieter, and low magnetic exposure. And the cons are expensive computer system for monitoring magnetic separation. The pros for EDS are longer lifetimes, lower operating costs, faster and quieter, and safer during outage. And the cons is significant cost for cooling conductive magnets.
Besides the maglev trains, there have been many modifications to the maglev concept in order to improve our facilities for a better and advanced future. Some examples are the Hyperloop, the Skytrain, the hoverboard, and the maglev wind turbine. First of all, we have the Hyperloop. This idea was envisioned by Elon Musk, who is the founder of SpaceX. The Hyperloop is based on using a theory of magnetic levitation and vacuum. Many companies have tried to turn this idea into reality. For instance, a company by the name of Virgin Hyperloop One have successfully made a big step in making the Hyperloop and have undergone several prototype tests. An interesting fact of the Hyperloop is that it can travel up to an estimated speed of 1080 km per hour, which is 2 to 3 times faster than maglev trains. Next is the Skytrain. It is developed by a company called Unimodel. The Skytrain is a lightweight 2-passenger vehicle which is suspended from magnetic levitation tracks. Departure and arrival stations are small enough to fit onto sidewalks and into office buildings. Therefore, they are convenient for easy transportation. The Skytrain is also low in cost and helps in reducing pollution. The following modification is the hoverboard. It is developed by Lexus. The hoverboard consists of ceramic tile superconductors which cause the hoverboard to levitate. However, it only works on a specially created skate park which contains magnets under the tracks. The superconductors are cooled using liquid nitrogen to negative 197 degrees Celsius to prevent the hoverboard from overheating. Despite that, the superconductors will still boil at that temperature. Finally, we have the maglev wind turbine. It consists of vertically orientated blades which are suspended in the air above the base and permanent magnets. One maglev wind turbine can supply enough energy for 750,000 houses, while a field of 1,000 traditional wind turbines can power up to only 500,000 houses. Furthermore, no energy is lost through friction during the rotation of the blades. Hence, this allows the maintenance cost to be reduced and the lifespan of the generator to be increased. All in all, I believe that magnetic levitation brings great potential to be utilized in modernizing the world. Therefore, we as a community should strive to apply the maglev concept in our daily facilities in order to aim for a greener and better future.